Good afternoon, everyone. Thank you for coming. I'm Phil Race. I work on the Java desktop client libraries. I've been doing that for a long time. I've spent most of my time working on things related to the Java 2D part of it. But overall, I'm these days responsible for the whole Swing and AWT stack as a sort of technical lead and open JDK. And I'm basically going to give you a pretty good overview of where we are and what we're doing and how we got here and so forth. And I've got this hopefully pithy title, 2026 and still swinging. And just, the longevity of this stack is actually quite impressive. And just, I think you've had plenty of time to read the little subtitle. This is maybe one of the few talks here today that is about UI, not AI. Okay, so what are we going to talk about? This is just a quick overview. How we got here, the kinds of things that we're doing right now. When I say projects, it's in a very general sense. Testing, the importance of testing to us and to the consumers of what we produce. The kinds of things that are our priorities that take up a lot of our time. Some of the things that I hope we'll be doing in the future. And then I'm fairly sure we've time for some questions and answers. Well, there'll be questions, maybe there'll be answers. So the journey. Right, so JDK 1.0 shipped in 1996 after the alpha in 1995, and it was a very small thing at that time, JDK overall. There were like 6 packages or something like that. There was the base Java Lang, Java I/O, Java Net. And then there was Java.AWT, which basically provided all of the APIs that you could use for creating a graphical user interface application with basic buttons and things like that, and a very primitive set of graphic primitives. And they were implemented as for just the two in the reference implementation of Java. They were implemented for just Windows and Solaris, if anyone remembers this operating system called Solaris. That was, and in fact, it was almost like the tier 1 platform at that time as far as Sun Microsystems, the developer of Java, was concerned. And we basically just the implementation just called through to X11 or GDI, and then there's an imaging API. So it provided this very primitive thing, but it also had this capability to run embedded using the Java applet package. This was interesting. It was devised for, like, as I'm sure people know, like for a set-top kind of environment. The Star 7 was a prototype device that was produced by the group that developed Java. It had a life cycle for these things called applets, and it provided the APIs that were provided by the rest of the Java APIs included things like networking, which is important for the new internet thing that was coming along, and also it provided the general notion of some kind of sandbox that these applets could run in, and because the idea is if you could have embedded applications that they would get code from somewhere downloaded off the internet, and you didn't necessarily want them to be able to do anything in your system. And things like Microsoft ActiveX, it is just unbelievable today to think that ActiveX just did not have that same kind of level of sandbox. And people's systems would have been taken over in a day if it was introduced now. So you could build fun apps and do business web apps, and by business I mean things that actually connected to your database, which really required a thing called JDBC. And the web browsers of the day, like Netscape Navigator and then Internet Explorer, picked this up, and you can see some of what they looked like here. And this was what the Java desktop was in 1996. And the internet and browsers were a key reason why people were interested in in Java, and really helped to found the entire success of the platform. So where are we now? Well, we still have Java AWT, but etc., etc. But this is now part of the Java desktop module. In JDK 9, the whole JDK became modularized. The Java desktop was a pretty huge module because it provided so many different packages and so much support, and there was no particularly easy way to separate it, and it just was not viable. So we still have the Java AWT package, which these days doesn't do the APIs that were there in 1.0 are still there, but the importance of some of them is greatly diminished. But AWT is still foundational for dealing with the interacting with the desktop, and has acquired new capabilities, many new capabilities along the way. JDK 1.2 had introduced Java 2D, which provided much richer graphics, much richer imaging, much richer text, and a much richer printing API, which was further developed in later releases. And then what really became the thing that everybody who was just wanted to write an application to interact with their users gravitated towards, which was Swing, a lightweight user interface library. And it's entirely built on top of AWT and Java 2D rather than just being dependent on the platform. Although the platform look and feels that Swing provides do leverage platform capabilities in order to do the rendering for that. And then there are other APIs like JavaFX Sound, which is not one that you hear about a lot, but it's still there. It still works very well. And relatively recently, I was surprised to learn just how interesting there are some people out there who use it because it can deal with multi-gigabyte MIDI files, which is apparently very hard to, not very many things can do. And there are other APIs like ImageIO I don't mention here. But so this is basically where we are. It has been essentially feature complete for quite a long time, and not that much has been added to it in recent years. And our focus is very much on maintaining and modernizing these things. And I'll talk about that more in a bit. And I also just want to mention the little asterisk that Java 2D is not just for for your desktop interaction in your native application, Windows Java desktop application, but headless servers use these APIs for various things, for rendering and printing. And as I'm sure you'll see, I've crossed out Java applet. That's just a brief image that everyone I'm sure has seen. So, Swing Set was just a demonstration of the capabilities of what we can do today. So the Java applet timeline, well, I took these pictures obviously right here and inserted them in, and it might be a little hard to see, but 1995, May 23/995, JavaOne announced with Netscape, included with Netscape Navigator browser, introduction of applets. And then we get to 2026, last traces of support for applets removed. I had nothing to do with the former, but I'm afraid I did have something to do with the latter part. So you can shoot me later. So JEP 504, which I always thought would have been better if it was 404, but never mind. Removed the applet API. This happened as far as users are concerned 2 days ago when we introduced JDK 26. And as I mentioned earlier, it was a core API back in the day, but its days became numbered as browsers became less interested in supporting it. As other people have mentioned, there are security issues with Sandbox. The Sandbox is there to prevent you breaking out if you're well behaved. But if there are bugs and you're not well behaved, then there are incredibly circuitous sometimes, but ways of breaking out of the sandbox. But the API surface of Java is such that it's very hard to defend against all such things. And also applets were, because they were small back in the day, the internet was so, people were using dial-up modems. It was very important to have something that was kind of small on the download. So once you'd got your browser, on your CD in the mail from AOL, people may not remember this, but and they would spam you with these things. So that was the delivery mechanism for the browser, right? And then you would get the applet over your dial-up line. But even over the last 10 years, people on their phone have been downloading gigabyte apps onto their phone. And so bandwidth is no longer a problem either. So JDK now provides JPackage, and I'll talk about it briefly. So we didn't do this instantly, and as far as we're concerned, we did not do it without warning. JDK 9, 2017 first deprecated the applet API. JDK 11, 2018 removed the applet viewer tool, which is just a tool that came with the JDK, just like Java and Java P and Java C and so forth. And this was essentially a developer tool so they could have a look at what their applet looked like outside of the browser. JDK 17 deprecated the applet API further for removal, saying it's not just don't use it, but at some point it's going away. So that was now 5 years ago. And then, in fact, there had been some thought about removing it then, but it was put off. Then JDK 24 permanently disabled the Java Security Manager. So the Security Manager APIs were not removed, but you could not enable a security manager. So basically that meant there could not possibly be a sandbox for untrusted downloaded code. So that was another nail, if it was needed, in the coffin of Java applets. And we went and ripped out a lot of code as a result of that too. JDK 26 has now removed the applet API. JEP 504 is the guilty JEP. It's enhancement proposal, whatever. Anyway, so yes, it's gone. And any class that actually referenced an applet, any method or class that referenced the applet API is gone. So Swing's JApplet is gone too. And at a Java API level, there isn't a replacement for any of that. Except that we did add a API called SoundClip, which was meant to be as pretty much a drop-in replacement for the applet audio clip, which was basically the only, I think it's a static method. It was basically the only thing that you could use from the entire applet package without support for the applet lifecycle. People have also, for what it's worth, pointed out that you could write an application that extended applet, and so you could run it as a main, where you had a container that extended applet, and you could therefore have a main program which called the applets in it and start methods. And so by taking the applet API away, those things are broken, which is true, but those did not have a proper applet lifecycle. There was nothing there to support it. The core JDK never had anything in it that actually supported the applet lifecycle. So all you were really doing was creating a panel, right? Applet is a subclass of Java panel. You were just creating a panel and drawing some content in it and loading it in a different way. But it seems unlikely that anyone would have a production applet that was extending some production code that was intended to be used on the desktop and extended applet in any way. But if they do, they've got JDK 25, which still has it, which is an LTS and is going to be supported for another, I don't know what the support policy is, 8 years maybe. Okay. So what do you do instead? Well, as I mentioned a few minutes ago, we no longer have the same sort of download limitation, bandwidth limitation in the world. People are used to downloading, watching movies on their phone, etc., etc. So you can, and if you want to, if you're not using a browser, something in the browser or something like that, then and you want something installed locally on your desktop, then you can download and install it using a native installer. And that would download a JRE that's bundled with your application. But again, this is, even with JDK today, this is going to be smaller than some phones that some apps that you can get on your phone. So JPackage is a tool that started off as a JavaFX thing called JavaFX Packager or something like that, and was migrated into JDK as JPackage, and it builds platform native installers. For Windows, you can have XEMSI, macOS DImage or .pkg, Linux, RPM, or Deb for Debian-based distributions. And so for, at least for the first two platforms, and arguably perhaps for Linux, that basically covers the different ways you would want to install an application natively. So it is just as if you were bundling up a C application or something to be, or C++ or Objective-C or whatever application to be installed on Windows, Mac OS. JPackage will produce an installer that is just as, gives the user experience exactly the same. I mean, when you're running the Java application, you can kind of go, oh, I think this is a Java application. But the experience of installing it and uninstalling it, etc., should be the same. And it's not hard to do this. Here, there are two commands really that are involved here. And this is even an example which is a fairly sophisticated one, because what I'm doing here is I'm building an application that mixes both JavaFX and Swing. And I'll go through roughly what we have here. So JLink, right, is a command that came in with the module system to basically build a custom JDK where you can potentially exclude certain modules. Say you only wanted to run some simple server application in a container or something like that. You could have excluded the desktop module. But it isn't just a matter of excluding things. You can add modules. And JavaFX has delivered, as well as a class path, well, as an SDK, there are also a delivery of JMods, which are a module system invention. And the JLink command can combine these to create yourself a custom JDK. And so I've got a couple of exports which point to where we can get the JMods for the JDK and for JavaFX. And then there's a JLink command. The first part is, whoops, that was not what I meant to do. I was trying to highlight with my mouse, but it doesn't work, of course. So enable native access is added because that, since JDK 24, because JavaFX is not part of the JDK, not a trusted module, you will get a warning when you try to use JavaFX, or in fact any library that uses native code that is not part of the JDK itself. And the only way you can disable that is on the command line, you pass enable native access. So the library can't say, I'm just going to hide the fact that there's native code involved in here. It actually is part of what's the choice has to be made by the end user, but except there's one kind of way past that, which is JLink can pass that. When you JLink, you can pass that as what's an implicit command to the launcher. So here we basically JLink these modules. We put the output in a combined JDK, JavaFX, and we're adding all the modules. And then with that is now the runtime image that I will pass into the JPackage command. And then I've got a jar, which is the application I want to bundle. I give it a name, which is what the application will be named when the end user sees it. I'm just saying where I actually want to put the output of this command. And the input, which is where my class files are, or my jar file. Icons to be used by the native application, and this is a Java option to basically say that when this application is in the dock on macOS, this is the image I want to use, so it'll just look like a native application still. Do I dare? Hang on. Do I dare have time to? So, and it's not hard to do. I just need to. Am I brave enough to do this? So the command, is exactly, well, I've got another level of whatever on there, level of directory. But if I run that, you'll see that it takes a little bit to think about it. But at some point you should see, there we go, it is actually creating a JMailD image. And if I had this right, yep, there we are, 231. So that's the actual D image that was just created. If I click on that, I can just drag that to applications, because I had one before, and boom, that's it. So that's an installed macOS application, which I could run now if I wanted to. Okay, let's go back to the slideshow. Will it continue from where I was? Please do. Dang it. Okay, I'm sure there's a way to do that. But okay, so that's the deployment story as to how you would replace applets today. There are other things you could do, but that's what we provide. Now let's move on to some things that we're working on, what I call projects in the intro slide. There's a proposal to create a Swing date picker. So a date picker is basically lets a user pick a date from a user interface that kind of looks like a calendar. JavaScript has these. JavaFX has a date picker, and there was a Swing date picker a long time ago in this sort of external thing called SwingX, which was Swing Experiments, which is a website where the people who were working on Swing at the time would prototype ideas of things that might eventually make it into the core Swing API. That's still out there somewhere. Some people have got it, but the SwingX website's been gone a long time. There are some third-party ones as well that people have developed, showing that there is a bit of a need. So, one of the people on our team suggested maybe we should think about bringing one into the core Swing API. Well, we haven't done a new Swing component for a long time. How interested would people be in this? So we did some surveys internally, and then an external sort of informal survey on our client list. And I think generally people were positive. There wasn't, I don't recall any, don't do this. So we started working on that. And we have been working on what our goals for this would be. And first, like the Swing date picker, like the FX date picker, we will return a Java time local date. If we'd done this a long time ago, before the Java time API, would have been a Java util date, and we would have regretted it ever since. But there's procrastination. So we want to be able to select the day, month, year. I'd still kind of like to find a way to make it easy to get a time out of it, but that's not a goal right now. Maybe it'll just be a way to, we'll show how to do that with your own code. I don't know. Select a date range, constraining the range, customize it in a bunch of ways. We'd like it to be, you could bed it or be a pop-up, and follow all the usual Swing conventions for basically working well with each look and feel, the MVC pattern. It should be internationalized, and it should support assistive technologies. And in the proposal we have, there are basically really two components. Well, there's a third, but there are really two components. What's called the JDatePicker. It displays the currently selected date, and JCalendar pane, which is the month view, and I'll show these here. So this is what it looks like in the Swing Set 2 demo. In fact, I'll show that in a minute. And functioning as a pop-up. So we have the what is the part that shows the date with the little icon that looks a tiny little icon next to it is the JDatePicker component itself. And somebody who works as actually at Oracle in the JDK group has promised us a much better icon than we have here, but I forgot to remind him in time for JavaOne. And the calendar, the month view there is the JCalendar pane, and we'll show more of these in a moment. Okay, so code. How do you use it at the most minimal level? Very simple. You say new JDatePicker, and then here in this simple UI, which is basically that entire program is it. We have the JDatePicker displayed, and we have a J label below it displaying the date, which isn't that today? Wow. Okay. But I thought I did this earlier. Okay, never mind. And so the J label is currently displaying what the dates are. It's actually not, since this is not set up to display a range, the dates are just a single date. You just have to add a change listener to the date picker to get notified of when the user edits it, clicks on it, selects something, does something. So you can just have it sitting there in your UI and just install a listener. So as you can see, the new code that you need to add to use a JDatePicker is very, very minimal. And that's all in red. So just take a note. And then if I go to the next slide, one thing changes to blue. I didn't change the names of the variables, although it's sort of a little odd. But all I changed is, say, use the JCalendar panel directly. And you can have the exact same thing. You didn't need to change anything else in the program whatsoever. You can just say, I want to use a calendar panel. And then this is what's embedded. The date picker doesn't appear, and you can actually just listen for changes on the JCalendar pane in exactly the same way. So some people might want the JDatePicker, which pops up the calendar pane, and some people might want to directly use the JCalendar pane itself. And there are certain things you can do in terms of customization. Here, I've basically just created a grid layout of 3x4 calendar panels. They're panels. I keep calling them calendar pane. I almost want to call it calendar pane because I call it calendar pane. Labeled with the month. The navigation that you will see here has gone away, because it doesn't make sense to navigate when you're actually displaying all of these. You don't want each one of these to be able to navigate to the next month. And this is the kind of one example. The font has been changed for the days of the week because I wanted a different font. So these are the kinds of things that we would like to be able to do in terms of customization. So let me just actually show some of this. Well, firstly, this is basically that demo there, and I can just click wherever I want to select the date from that. And then, okay, you can go away. Swing set 2. Hello, did I click? Okay, I didn't click. So swing set 2 has now got another demo pane, And so you can just go into this and play with it. This is the exact screenshot that we saw earlier. And here's one of the customizations that's got it built in. You can say you want to show the week number. Apparently, that's quite a common thing for people to want. There's JCalendar pane embedded. Double date picker. So these two are set up to be coordinated so that if I can't, I believe, go past. Oh, why has this one not got the navigation pane on it? Okay, but anyway, I can't change this to. I can change this to 2025, but I should not be able to change it to 20. Well, okay, there we go. It's not working as well as I would have hoped. But the idea is you should not be able to move the start date past the end date. There's localization. So here we have mats. I don't know what, and I'm sorry, I don't know how to say that in Japanese. But basically, it's localized, and the dates can be formatted in different ways as well. And if you ask me, that's not working. But in theory, okay. I should have looked harder at that. I must have regressed in the recent build. Okay, that did work. Demos, I love them. Okay, all right, let me quickly move back to the slideshow. Play from current slide, that's what I wanted. Okay, so JDatePicker is being developed in the JDK sandbox. So we obviously are still working on not just the bugs, but we're working on what we actually want it to do, the details, the features, how it feels, etc., etc. And so that's going to take a little while for us to work through. And so it's been worked on in the sandbox. You want to try it, you can follow these steps here. Go clone that, check out the DatePicker preview branch, build it, and then and go ahead and run it or try your own applications. What else is going on? OpenJDK project Wakefield. Okay, this is a bit of a gear switch from Swing in a way. So for people who aren't Linux users, they may or may not have noticed. But anyway, so the Linux desktop for since the beginning was based on X11. But over quite a significant number of years now, actually, a completely different technology called Wayland has been worked on, and there's no X11 involved. It's a completely new compositing desktop, and X11 applications, when it's running, only can run because there is a shim called the X11 compatibility layer. When a Wayland application is very different than X11. With X11, you could remote display the server. There was a protocol. You would talk to the server and tell it things like, ask the server what fonts there were. You then say what font. You would issue drawing instructions to draw a rectangle or draw some text and things like that. No, nothing like that. Basically, it provides you a surface. It says, please draw upon this surface now and tell me when you are ready. It's like doing OpenGL or something like that. And this actually, ironically, maps much better to Java 2D than X11 ever did, because really the X11 protocol didn't do enough for us, and we would use extensions, etc., etc. In Wayland, even the window decorations are drawn by the client. There's no window manager as such drawing that for you. And at the low level, the equivalent of Xlib is something called libwayland, but it's even lower level. Like I say, it doesn't provide any kind of rendering. It's just about events, surfaces, things like that. GTK is how I think Wayland people think most people would write a Wayland application today. So for years, the distros, if you were to pay attention on the actual login screen, there'd possibly be a little widget somewhere, and it would let you choose between the so-and-so desktop and x.org. And the x.org basically did not have Wayland. It was just like running X11, pure X11, a pure X7 server. All of the current distros have made that go away. It's just gone. So we knew that was coming, so for a number of years we have been working on this Wakefield project. And as well as Oracle, we have very significant contributions from JetBrains. And also Red Hat's GNOME desktop developers don't work on it, but they are there as a liaison to the Linux desktop community. So X11 compatibility mode, if we have a Wayland server and it does not support X11 at all, how do the thousands of X11 applications run? Basically, there's an X server integrated into that Wayland compositor. So if you're an X11 application, which is really what JDK is today, it says, where's the X server? And this thing answers on TCP port 6000, and we're good. Sort of. Various things didn't work perfectly. There were lots of tests would fail, various things like that. But one of the most problematic things is that an AWT API called Robot, which was used for event synthesis, screen grabs, things like that, just didn't work at all due to policies of the Wayland compositor and their everything about how they think a desktop should be. So we had to completely re-implement that, and it even caused us to have to change the Java SE specification. And that was a particular problem in that, it's fine, we delivered that in JDK 21. So JDK 21, we'll say, yes, this can run on a Wayland desktop and be compatible. But that would not be enough because we knew distros were coming along that only supported Wayland, and we needed to still support JDK 8, JDK 11, etc. So that meant we had to do a special thing called the maintenance JSR, and that was backported to all these different trains. And the focus of the project has now moved on to a Wayland native toolkit for AWT. It's hard work in some ways. Where do you actually work? Do you try to use GTK or do you use libWayland for the first decision? And we went libWayland. And JetBrains are actually the people who are really doing the work on this right now. And one of the other things that we're hoping to get out of this is a Vulkan pipeline. The software pipeline, what we call the software pipeline, where Java 2D just draws to a surface and we blit it, works perfectly well and quite well. And in fact, we even use that a lot on Windows. But Vulkan is a replacement for OpenGL, and we hope that that will make its way into JDK, and it may even come in before the rest of Wayland. But Wayland not reporting window locations, basically it says your surface is 0, 0, is a particular problem for testing, and I think to a significant degree for applications as well that want to lay themselves out with respect to other windows that they've created. So possibly how will we bring this in? Maybe we've already done the X11 compatibility layer. The next layer might be the Vulkan pipeline, because we've done pipelines before. And I think we'll have a number of EAs before we actually get to be able to integrate the pure Wayland toolkit once we've figured out how to deal with all the problems. But again, it's something you can try now. There's a project. It's in its own repo. The pure Wayland branch is the one that actually has the latest work in it. What else is going on? And we are modernizing the Java 2D pipelines. Over time, we have rewritten or created a new one for the Apple Metal API on macOS to replace OpenGL, which they have deprecated. FX is almost done with a D3D12 pipeline. They currently use D3D9, and I'm hoping that a lot of that can actually be copied over to JDK, just like went the other way, where FX basically was able to leverage a lot of the work we'd done on the Metal pipeline for Mac. And then I just mentioned Linux, we might get a Vulkan pipeline, because right now we'd really just it's really just X11 with some X-render. What else have we been doing? Panama, Foreign Function and Memory API. Native code without JNI, well, yes, we have a lot of native code. There are over 1,500 JNI methods, but there's no way we could kind of say, let's re-implement everything like that. So there was a little bit of, I know Sergey looked at some of the color management stuff as one possibility, and I looked at some of the one native library we use, and actually that has been re-implemented to use FFM, the way we access that native library. But it was a very valuable learning experience. At first I wrestled with whether to use JExtract, because the font data that we need to, this basically does OpenType layout reading font tables, and the font tables are read using Java I/O, right? And so we needed to call up back into Java to get font data. And FFM is really, there are upcalls, but we also had upcalls which needed to pass around Java objects. And binding handles to these turned out to be extremely expensive. Especially in startup cost. So something called scope values, which is now in the JDK, basically a kind of thread local, is used so that when we call down, and when you call back up again, in the context where you're going to call down, you establish some scope variables. You call down, whenever you call back up, you can just find those variables from the scope. We also were able to migrate using FFM away from some uses of sun, misc, and unsafe. And I've thought about it. It's a lot of work, but XOR sort of maps quite nicely the way it's implemented to being ported to FFM. What else? The security manager was ripped out in 24. I mentioned that. So that was a lot of work just to be able to get rid of all the tests that would fail before the security manager could even be removed. But once that disabling was integrated, we had hundreds of places inside for that applet sandboxing, right? And for when the security manager was running, to assert permissions or do things in special ways. And that code was dead, so we had a lot of fun ripping that out. People were on that. No problem. Not just within the client or desktop module, but across the JDK, people were very happy to get rid of that. And JDK 26 has removed the applet API. So there's an internal thing called an app context, which is not yet gone, but I am doing my best to get rid of it as quickly as possible. But it's not just a rip out thing. Understanding what it does and how to replace it means that it's a little slower per case than ripping out the security manager, but I'm hoping to get that done quite soon. Anyway, so we'll hopefully have a more clean implementation, got rid of some technical debt. Another piece of technical debt that we've been working on is getting rid of finalize. There's a wider JDK project to get rid of object finalization, which is considered to be problematic, but was very widely used in a lot of APIs and internally. And we've managed to rip it out of most of the JDK uses right now. There's some stuff still in macOS implementation, CF retained resource. Java Sound makes use of it. All of the others are either gone, or if there's still a finalize method there, it doesn't matter to the JDK. I'll very briefly talk about UI testing. There's a lot of words on these slides, but UI testing, we have a lot of tests, and that's good. We have thousands of tests. Many of them are automated. And so you think a developer could just sit down and run them, but they would still, and then know how well a change they'd done were proposing would work. But they would have to run them on all platforms potentially. And many of these tests, because they weren't run very often, they were actually known to fail. And SQE knew that they would fail, and SQE would file a bug, but keep a list over here. And it was very painful to know that you didn't cause any tests to fail. SQE might eventually tell you when we got to the end of a beta cycle or something like that, and we'd run all of the tests. This just was not viable with a 6-month release schedule. So we now, internally at Oracle, we have a CI build-in test system. It's called Mach 5. Obviously, this requires automated tests. A great number of our tests are automated. But it also supposes that all the tests pass. If hundreds of them fail, nobody will know what's going on. And then, even if they pass they can't just pass half the time. They've got to pass all the time, or as much as, very, very rarely fail, because these tests could be run dozens of times in a day. So UI testing is hard, automated UI testing is harder, reliable automated UI testing is very hard indeed. And when you're testing on a desktop, you are at the mercy of what the vendor does in terms of deciding that please have this new little weather app widget which grabs focus. And so if you just try testing on that desktop, your tests start failing as this thing comes up. Or macOS really wants to inform us that Valentine's Day is coming up, and this thing just pops up and tests fail. Anyway, and we also really need to be able to run on physical machines as well, because not everything is real world in the otherwise. So we have spent a lot of effort on trying to get these tests to pass reliably, etc., etc. So this helps, us internally, but ultimately I believe it also is interest just, to you guys, because the end result is that we're able to develop fixes faster and have no regressions, I wish, but fewer regressions, right? I mean, you can have regressions just because we didn't even have a test in the first place, right? Okay. Day-to-day stuff. Well, security with the sandbox matters. We removed applets, but the compatibility of people who are using the APIs as designed, that does matter. We fix critical bugs. We care about new platforms, and we're getting better at that. We do fill some feature gaps, the modernization and other things I've talked about, and we care about performance as well still. And we've been working, reasonably consistently over a number of years here to try to, continue with all of these routine tasks, upgrading third-party libraries, etc., etc. And this is raw data, but that's just at a 6-month release. We fix a number of different issues. So what might come in the future? I've touched on some of these already. The first 3 I've touched, and basically hoping that these will happen in the next release or so. Other things that are in the pipeline, open type font variations and other support for fonts. The Wayland stuff I mentioned is still some way out. D3, D12, we haven't started on that yet, below we have the FX work. Maybe some more FFM. The vector API, I would love to use that for some of our imaging stuff, but a Java SE module cannot depend upon an incubator module, so it's not possible for us to do this until that becomes final, or at least preview, which depends on Valhalla. So, okay, so in summary, we're maintaining all of this stuff. I think one of the JetBrains guy this morning, Anton, I think his name was, remarked that IntelliJ is based on Swing and has been for 25 years, but which is a little hard to believe, but it shows that we're keeping up and modernizing. So with that, I think I'm done. And anybody who's interested can join the client libs dev list at openjdk.org. Thank you. And I might have talked longer than I expected. I don't know if there's time for questions. Okay. Add what, sorry? AOT. If there was an AOT bundle, I think JDatePicker would be able to take advantage, or it would certainly happen, yes, let's put it that way. If there was an AOT bundle, but I do not know if are you talking about using Leiden, something like that?
Yes, to have a .aot file that I generate.
JPackage will package up anything you want. So if you had your yeah, the trouble with the Leiden stuff is it really needs to be run on the system you're going to deploy it on to be best. Since you have this talk's not really about JPackage, but anyway, JPackage installers are per platform, right? So you might find some advantage from it, but what I've heard is that certainly if the Java code is all the same and everything is the same, there's a reasonable chance you will get some boost out of it at startup using that. But obviously it's not going to be targeted to precisely the system. Although the same could happen in any kind of Leiden thing, usage where basically you profile it on this system and then you deploy it in your environment, and you've got systems that are 5 years old, 1 year old, 3 year old, with this and with that, and yeah. So I think it should work as well. I don't see why you couldn't deploy it as using JPackage. Can't think of a reason why not.
Or something.
So the question is, will things like the swing table model API change to not use Java util vector, but to use some more modern collection type? Is that the question?
Yeah, it's not even typed. The vector is not typed right now. It's like raw.
Oh, it's just an object or something?
It's a vector, but without the generic type.
Oh, it's just, that's what you mean. Yeah, it's just a generic, it's a non-generified vector. Oh, so add generics to swing. Is that the question?
Some are done, like JCombo is all kind of okay.
So a very long time ago, that was looked into, it didn't go very far, and I'm not sure I want to be 100%, can't be 100% sure of remembering why, but I think there were compatibility concerns was the short answer that I remember, is why it didn't happen then, which makes it probably, that would not change, I guess, so probably not. It would have to be very selective and definitely compatible, but generally going across and generifying swing was considered that there were going to be compatibility issues. That's how I remember it. I wasn't involved, it was just what I was told. As I remember it, with all those qualifications. I mean, it would have to be a case-by-case basis rather than just blithely going in and adding implement serializable, Any other questions? Nope. Okay. All right. Thank you, everyone.